Hello. Good afternoon, students. So today we are going to first of all revise the topics that we studied in the last lecture, and then we'll talk about a new resource, that is your mineral resource, types of mining, and we are going to talk about biodiesel. Okay. So let me just share the previous slide with you so that we can go through it and then start the new topic. So I shared this slide with you on WhatsApp. I hope you have gone through it, but just for your revision's sake. In the previous class, we were talking about geothermal energy. So this was the image that I showed you. If anyone has a doubt, then they can let me know. Okay, then we were talking about different types of ocean energies. Okay, different types of ocean energies, which had three subdivisions, which was your tidal energy, wave energy, and your ocean thermal energy. So when we were talking about tidal energy, this particular energy was based on the potential energy of water as and when there is a high tide or low tide. So high tide is usually seen on full moon days. Okay, but on usual basis, in one particular day, any dam or any tidal barrage sees two cycles of high tide and low tide. So in 24 hours, there are two high tides and consequently two low tides during 24 hours. So we store that particular that water which is seen in rising in high tide and use that potential energy to turn the turbines. So this was the basic introduction about your tidal energy. So for that same, I had shared one schematic with you. So I hope you have gone through this. And the next type of energy was your wave energy. So when we're talking about wave energy, then these structures, as you can see it in the image, such floating generators are placed in open waters, and due to this wave energy, the wave basically this high kinetic energy wave, you can say it a high kinetic energy wave, it moves into these generators and compresses the air present inside these generators as shown in the second image. So this compressed air has some energy and that energy is used to turn the turbines. Okay, so this is what happens in your wave energy. The next one was your ocean thermal energy. So ocean thermal energy was based on one basic factor, that water on the surface has got a higher temperature in comparison to the one at the lower temperature. So that if we calculate or if we try to figure out the temperature difference, then in a range of 2 kilometers, the temperature can vary between 10 to 30 degrees Celsius. So depending upon that, the temperature difference, that water is used for condensing and vaporizing ammonia. So the basic concept between this ocean thermal energy is condensing and vaporizing ammonia. So vaporized ammonia like steam is used for turning the turbines, but since ammonia can be reused as it's not getting involved in any kind of reaction, then it's condensed again with your cold waters as seen in your image here. Okay, so this is what happens in your ocean thermal energy. So there were a few drawbacks related to these energies. First of all, the cost involved, and then the maintenance, और जो third factor था वो था location. Okay, all these types of energies are placed away from the place of requirement. So we are not able to harness this energy properly. So this was what was happening in your ocean thermal energy. Then we talked about your green fuel, which was your biodiesel. Okay, so let's just study about the reaction involved in biodiesel because it's usually asked in examinations. So I'll share that slide with you and close this present point. Okay, so we were talking about your renewable resources. So we have done solar energy, geothermal energy, ocean energy, wind energy. Okay, so these are the ones which fall under the category of renewable energy. You can go through the table to understand their limitations and advantages. Okay, and their efficiencies also. So all this has been provided in notes, but the schematics for the instruments or the working is given in a separate slide. I hope all of you have gone through that. So just have a look at it and let me know if you have any problems. Just send a screenshot and I'll answer your queries. Okay, so we were talking about your non-renewable sources of energy. So when we talk about non-renewable sources, then we have read about coal, petroleum, natural gas, etc. And then the next one was your nuclear energy. Another one was your source of green fuel or biofuel. So when we came across biofuel, we learned that biofuel is nothing but trans-esterification of vegetable oil. Okay, so this particular vegetable oil, as we read, can be obtained from different sources. So the sources can be your palm oil, sunflower oil, soy oil, jetropa oil, or even nowadays जो cooking oil है which is left unused, even that can be used or utilized for synthesizing your biofuel. Okay, so this was a setup which is used for getting vegetable oil. So what we do, we take the seeds, we crush them and collect the oil present in those seeds. Okay, so whatever is left behind the pressed tablet, the waste, the plant product can be used as a manure. Okay, but the oil is used for your biodiesel purposes or synthesis of biodiesel. Whatever the benefits for biodiesel were, first of all, it's non-carcinogenic, non-mutagenic, and has got a very high flash point. That's what we learned. So in comparison to your petrol and diesel, due to the higher flash point, its transport is easier. Okay, so this was what we learned about biodiesel. So environmental benefits may I talked about carbon sink and carbon sequestration. So when we talk about carbon sink, so carbon sink is related to the fact that the forest or any forest or grassland plant area, any area which has got a very high density of plants is called as a carbon sink because plants use carbon dioxide for photosynthesis. So they have the ability to absorb carbon dioxide. So it can be called as your carbon sink. And carbon sequestration. So sequestration is basically, like I told you, sequestration means reducing the amount or the effect of any particular pollutant or any entity to a certain level. So plants help in that. So that was what we were studying about. So let's just learn the reaction involved in synthesis of biodiesel. Okay. So I'll stop the slide here and take you to another slide. So this is your synthesis of biodiesel. So when we talk about biodiesel, the first fact that is involved is that it sources your vegetable oil from any type of plant material, okay, or even used cooking oil. So the reaction involves first of all vegetable oil or any oil which has got fatty acids and treating it with methanol and NaOH as a catalyst. So the final product that we get is your mixture of fatty esters and glycerin. So what is happening? This is a base catalyzed trans esterification reaction. Okay. So this is a base catalyzed. So when we talk about base, it's either NaOH as already written down, or you can use potassium hydroxide and trans-esterification reaction. So when we talk about trans-esterification, it means taking a functional group from alcohol and another from acid. Okay, or ester, you can say, any fatty acid. Yes. So what is happening in this particular thing? This is a fatty acid or a oil. We have methanol and NaOH. So the first reaction that is involved is mixing of the catalyst with the reactant. So here NaOH is the catalyst and CH3OH or methanol is your reactant. So what is happening? This NaOH is breaking down into its ions in the presence of methanol as a mixture is formed, and we have Na plus sodium ion, OCH3 minus ion and H2O. So this particular OCH3 minus ion, it reacts with your this group. Okay, basically the group that has been taken from your acid. So what is the product that we are finally getting? We are getting an ester. What is ester? Ester is RCOR. So basically acid is H3COOH, acetic acid. Okay, so let me just write it here. If we talk about acid, formula is, let's just say CH3 H. Okay. But when we talk about ester, it is your CH3COO R. So when we have a functional group and an organic group or any organic hydrocarbon chain attached to your acid in place of hydrogen, it's your ester. So that is exactly what is happening in this particular reaction. A fatty acid is taken. Now this particular RCO group reacts with OCH3 minus group and forms an ester like this here. So there is another product that we get, which is your glycerine. So this biodiesel reaction basically is helping in both ways. First of all, it is providing you a biofuel. Then the second product, that is glycerine, is also acting as a important product because it's used in your cosmetics or and as well as in your industries and other chemical reactions. So this particular reaction can be called as a good reaction. Okay. So we'll talk about the reactions and how the reactants and their products are related when we talk about green chemistry. But this particular fuel or this particular reaction works in uses a method of esterification. Okay, so किसी को अगर इस particular reaction में doubt है तो अभी पूछ लो. ये एक fatty acid है. This triglyceride can be taken from any particular seed, vegetable oil or any sunflower oil, groundnut oil, jetropa oil. कोई भी एक ऑयल जो वेस्ट ऑयल है या फिर कुकिंग ऑयल जो वेस्ट ऑयल है जिसमें ये फंक्शनल ग्रुप प्रेजेंट हो, फैटी एसिड प्रेजेंट हो, उसको लेकर के methanol के साथ react करना है और NaOH is used as a catalyst. So the reaction that is happening between your methanol and your sodium hydroxide is given here. First of all, methanol and sodium hydroxide are mixed. The first step is here. It's mixed and we get three ions. Okay, we get a sodium ion, we get this particular ion, and we get H2O. So this reacts with your RCO group and forms a ester. Now I've already told you esters have this functional this chemical formula. So this is a CH3 group and we have COR as shown in this general functional formula for an ester. So we get a biodiesel and glycerine. So अगर किसी स्टूडेंट को इस particular reaction में doubt है तो वो पूछ लो, otherwise I'll take you to the next slide. So when we talk about India, there are various plants set up in different states. So we have Ruchi plant in Gujarat. Unicorn Fibrochem also produces biodiesel in Silvassa. Another one is in Rajputana Biofuels Limited, Jaipur. And there is a list given. You can just have a look at it. Okay. So is biodiesel being used in vehicles? That is the most important question. कि synthesis तो कर लिया in research lab, in industrial processes, industrially आपने synthesize कर लिया, but is it finding usage in regular practice or in any is it having any practical use? So yes, it is being used in a certain ratio. So what is the ratio? The ratio is B20. So the most common biodiesel blend is B20, which ranges from 6% to 20% biodiesel blended petroleum diesel. So B20 means 20% of biodiesel and 80% of petroleum diesel. When we talk about B5, then it means biodiesel blend is 5% and diesel is 95%. So this is the blend which is being used commonly in different countries. So B20 and lower blends can be used mainly in many diesel vehicles without engine modification. So this is important. Okay, so what is the benefit of using biodiesel? It raises the cetane number. So like octane number for petroleum, cetane number is used for diesels. Okay, so higher the CPA number, better is the efficiency of any particular diesel. So for biodiesel, if you mix biodiesel with the regular petroleum, then the CPA number rises. So there was a news back in 2016 that German automaker Mercedes-Benz has proposed to shift the the diesel cars and other vehicles in India to environment-friendly biodiesel, but still this process is going on. It is the only alternative fuel which has been approved by Environment Protection Agency USA. Okay, so this is one of its. This is one of the information related to your biodiesel. So in India, National Policy of Biofuels was designed in 2018, which includes harnessing of biodiesel to meet the energy security of India. And this particular policy also targets on increasing the biodiesel blend. Currently, the biodiesel blending is less than 0.1%, but they are targeting it to increase to a higher percentage. Okay. So when we talk about World Biofuel Day, it's 10th August. So this is what is there to be learned about your biodiesel. So there are three key factors. First is that a biodiesel blend is used under the name B20, which has got 20% of biodiesel in it. So what is biodiesel? So biodiesel is a fatty ester obtained from plant or vegetable oils. Okay. So why are we using only B20, not B30 and B or any percentage above that? It's because B20 or biodiesel blend ratio B20 or anything lower than that does not require any engine modification. So this is the reason that in the present usage B20 is used or 20% of biodiesel is blended with your petroleum diesel. This is the basic factor. So if you want to use higher amount or if you want to use 100% biodiesel, then you have to modify the engine, but which is not practically available as of now. Okay, so this is all about your biodiesel. So if anyone is having any doubt or questions related to it, then just let me know. I have marked the important points for your understanding. So otherwise we'll move to the previous slide. Okay, so today we are going to talk about the mineral resources. So when we are dealing with mineral resources, there are four major compounds which are found in India. First is your iron, then it's a copper, lead, and manganese. Okay. So India is rich in mineral resources. There are abundant reserves of iron ore, mica, manganese, titanium, bauxite, and coal. But there is a deficiency of copper, lead, zinc, and gold. So this is the reason that all these compounds are imported. The country earns foreign exchange from the export of minerals like iron ore, titanium, manganese, bauxite, and granite. See, basically, this particular topic or this particular unit, natural resources, deals with the resources that are available in India and how they are benefiting us. Okay, so in the previous lectures, when we talked about your forest resource, when we talked about water resource and energy resource, we dealt with the situation that and the resources that are available in India. So in the same line, when we talk about mineral resources, then we are talking about the type of resources that are present in our country and where they are present. Okay. So when we talk about iron ore, so iron ore is Fe3O4 or magnetite. It's used in machines, agricultural equipments, and for in the items of general load. So basically, iron is found everywhere, whether it's construction of house or furniture or anywhere, iron is used. So 20% of the world reserve of iron ore is found in our country. Mines are found in Chhattisgarh, Jharkhand, Odisha, Goa, and Karnataka, and it's exported to Japan, Korea, and European countries and Gulf. Okay, this is an image for iron ore, Fe3O4. When we talk about manganese, it's used for making alloys using iron. Industrially, it's used for manufacturing bleaching powder, insecticides, paints, and batteries. One-fifth of the world deposits are found in India, second holder after Zimbabwe. So India has got a rich resource of manganese. Manganese ore is MnO2 or pyrolusite. Okay, so the main reserves in Karnataka, Odisha, Madhya Pradesh, and Maharashtra and Goa, and this is how it looks like. When we are talking about copper, so copper is used in electrical wires, utensils, and alloys. India contains less than 1% of the copper, and hence its mining and smelting is a costly thing. Okay, where it's found in your Madhya Pradesh, Rajasthan, Jharkhand, Karnataka, and Andhra Pradesh. The production of copper is less than 1%, so it's imported. When we talk about lead also called as Galena, which is your the formula is PBS. It's a soft heavy metal and bad conductor of heat. It's used in cable covers, ammunition, paints, glass, and rubber making, found in Andhra Pradesh and Tamil Nadu. India produces 25% of its requirement, and therefore rest is imported from Australia, Canada, and Myanmar. So basically, copper, lead, they are basically deficient in our country. Therefore, they have to be imported. So when we talk about bauxite, is aluminum hydroxide. It's used for making utensils, household goods, and India has got a vast reserve of bauxite. Whereas for mica, 60% of the world production of mica is done in India, and it's found in Jharkhand, Bihar, Andhra Pradesh, Rajasthan. Limestone is calcium carbonate, okay, जो chalk होती है, ठीक है. So 75% of it is used in cement industry, and rest is used for smelting of iron and chemical industry. So these are the places basically where these ores are found, and there you are listed their usage also. So you can go through the slide. I'll take you to the next slide, which is important. So how a mineral wealth is explored. So the first task of exploration is that the geologists basically they perform a survey aerial, they do aerial photography, remote sensing, and global positioning. Then drilling is one of the method which is used for collecting samples below the surface. Okay, so common salt, magnesium, and bromine are largely derived from ocean waters because oceans are also rich in your minerals. So common salt, that is NaCl, magnesium, and bromine are derived from ocean waters. Okay, so there are three types of minings which can be performed for extraction of ore. So the first type of mining is open pit. So open pit mining means a large hole or quarry is dug in earth in the area of ore and extracted. The second type of mining is strip mining. So when we talk about strip mining, long trenches are dug to get minerals. The series of strips are dug parallel to each other to extract minerals. So the rows of dug out material is known as spoil banks are created on surface. Okay, so we'll have a look at the image, how they look, and then you'll understand it better. The next type of mining is surface mining. So when we talk about surface mining, the mineral is above or just below the earth's surface. So it can be extracted by just digging out and making a large hole, by creating or drawing strips, long strips, and then there is subsurface mining. So subsurface mining is used for materials which are found deep inside the earth. So, for example, coal. So, if you want to extract coal, in that case, you have to uh, do subsurface mining. So, for that, tunnels and shafts are used to reach the mineral, and it's more expensive and complex form of mining requiring tunneling and transportation. So, environment is not visibly harmed, but there is a lack of risk of roof collapse, explosion of gases, and disturbance of underground water movement. So these are the things which are basically involved in your subsurface mining. So although on surface the ecosystem, the biodiversity is not getting disturbed, but underground, because of drawing tunnels and trenches to get the mineral out of the earth, there is a risk of light. Okay, so because of explosion of gases, risk of roof collapse, etc. So there is a lot of risk involved to the people working there. Okay, so the next step is processing the minerals. So when we talk about processing, the first step is to grinding and crushing. So once you take out the mineral from its mine, you grind it and crush it, and then sorting is done. The next step is smelting. Okay, so when we talk about smelting, smelting is heating the ore at high temperature. So iron is smelted at a temperature of 1535 degrees Celsius to 1600 degrees Celsius to take the ore out of it, because it is having a lot of impurities at the time of mining. So it's heated or melted, and what are the compounds or elements that we get out of it? It's silicon and phosphorus along with copper. Whereas in copper smelting, we get sulfur and other materials. Okay. So the last step is purification. So once you have done smelting, once you have melted that particular ore, the last step is purification, and the waste left is called as tailing or slag. Okay. So we were talking about three types of mining. So basically, we know that mineral resources are found in different states of India, specifically in the central region. Okay, Jharkhand, Chhattisgarh, Madhya Pradesh. These are the regions which are rich in mineral resources. But then we talked about how to extract those minerals. So the first task that is done to extract any mineral is to analyze or survey the area where there is a possibility of finding that ore. Okay, so this particular task is performed by geologists or scientists. They take samples of the soil present there, figure out which type of ore is present, and use the uh, use mining according to that. Okay, so if the material is found on the surface, let's just say we are talking about calcium carbonate. Okay, if that ore is found superficially on the surface or just slightly below the earth's surface, then open pit mining, or I'll show you the next slide, strip mining is used. Okay. So for all the minerals which are found on the surface of the earth or on the earth's crust or slightly below the earth's crust, open pit mining or strip mining is used. तो इस type के queries या large holes dig out कर लेते हैं, and then your ore is extracted. But if we talk about coal, this is an image for open pit mining, and this one is an image for strip mining. So this is the long strips are drawn to extract the ore. But if we talk about coal, then coal is found deep inside the earth. If we talk about gold, that is also found deep inside the earth. So for such purposes or such ores which are found deep inside the Earth's crust, then we have to use subsurface mining. Okay, ores found deep inside the Earth's crust. So for such ores, we are using subsurface mining, coal, gold, etc. So for that, tunnels and shafts are used for extracting that particular ore. But what is the risk involved? The risk involved is your loss of human life because of accidents or explosion of gases or movement or shifting of underground water. So that is the risk involved. Whereas in case of open and strip mining, the basic disadvantage is destruction of biodiversity, because the area where such holes and such strips are drawn, then there is a loss of biodiversity. So strip mining is used for ores found superficially on Earth's surface. Same is with the open pit mining. This particular type of mining is also used for the ores which are found superficially on Earth's surface. Okay, so this is what is meant by three types of mining. I've shown you the images for better understanding. Now let's go to the previous slide. So now you know what is meant about what I meant by open pit mining and strip mining. So digging a long trench to get minerals, a series of strips are dug parallel to each other to extract minerals. Okay, so subsurface mining is also clear. So when we talk about processing, so processing may the first step is to grind and crush that particular ore to achieve required size and grade, then sorting it out. So valuable material is separated from the ore using water. So whatever material that you get after crushing is washed and cleaned. The last step is smelting. So smelting means heating that particular ore at a very high temperature. So if you want to extract iron out of any ore, then you have to heat it at a temperature range of 1535 to 1600 degrees Celsius. So once you do that, iron will melt and it will separate out, whereas other elements like silicon and phosphorus can be separated by using different methods. Okay. So if you want copper ore, like if copper oxide is heated, then you get sulfur and other materials. So sulfur is the main material which is used. So smelting is basically nothing but heating at a very high temperature or heating at the melting point of that particular ore which is required. Okay. And the last step is purification. So once you purify it, you can use it for commercial or industrial or domestic purposes. So conservation of minerals. So why do we need to conserve the minerals? It is because of the strong dependence on mineral deposits in various industrial processes. So basically recycling metal scrap like steel, copper, aluminium, zinc, etc. Okay, so we were talking about conservation of minerals. So basically conservation is important in order to replenish the earth's resources or natural resources. Okay, so to do that, one should focus on recycling as well as using low grade materials. Okay, so basically utilization of low grade minerals, mineral waste should be encouraged in order to preserve the resources. Environment gets adversely impacted in the process of searching for mineral. So good practices should be introduced to help the environment. What are the factors involved in mining? So mining damages the Earth's natural landscape and forest ecosystem. So when we talk about natural landscape and forest ecosystem, we are talking about open pit and strip mining, because these are the minings which you basically use the land surface. अगर किसी forest area में if you are trying to do mining, then and specifically open pit mining or strip mining, then you have to cut down the trees for that particular area. Okay, forests are destroyed and wild animals are driven away. Several species become extinct. Another basic disadvantage is topsoil is removed and tailing piles lead to pollution in water. So when we talk about tailing piles, what is meant by tailing piles? Tailing piles. These are the clusters of waste left after the process of mining. Okay. So let's just, we are talking about iron, then iron extraction के बाद smelting और purification के बाद जो waste बचता है उसके piles या waste material है वो pollution करते हैं water में. How this happens by runoff during rainfall or absorption by groundwater. So this is what is meant by the topsoil is removed and tailing piles lead to pollution of water. So when we talk about iron ore, also contains sculpture. Therefore, acid. This is not sculpture, students. This is sulfur. Spelling mistake. Sulfur. So this sulfur obtained from iron mining causes acid rain its runoff. Okay. So this is what happens when we do mining. So waste disposal, 80% or more of the ore may be wasted after processing. And tailing can be used to fill the lowland areas. Slag, a source of phosphorus and calcium, can be used as a fertilizer. So basically emission control. So steam, smoke, particulate matter and other materials will be released by mining, causing serious health problems. So when is this particular issue seen? This particular issue is seen during smelting. That is when the ore is heated. At that time, different gases, if, different gases are released. So ये जो भी gases release होती हैं, all these gases can cause serious health problems to the people located in the nearby regions or the people which are involved in this processes. Okay, so using of coal in smelting process causes air pollution. This is also one of the other factors. Minerals also give gases like sulfur, nitrogen, and carbon, which are commonly released due causing air pollution. So this has to be taken in control. There is an act, the Clean Air Act and Clean Water Act, which says all mining activities are covered under such acts, and this particular act focuses on this act focuses on drawing attention towards control of such pollutants. Okay, so the mining activities. Okay. So this is what is meant by the Clean Air Act and Clean Water Act. So all mining activities से जितने भी pollutants निकलते हैं, then mining industry should take a check of that. Okay. So this is what is all about your mining resources. So इसमें कुछ important points हैं. Let's just go through them. So has got a deficiency of copper, lead, zinc, and gold, and whereas it has got an excess of iron ore, manganese, titanium oxide, etc. Okay, so there are three types of mining. So depending upon where the ore is found, it can be either surface mining. So if a question comes, explain about the what is mining and the types of mining, then there are two types. First is surface mining and the second one is subsurface mining. So surface mining में दो types है, open pit and strip mining, whereas subsurface में you draw tunnels. ठीक है, और कहाँ कहाँ पे यूज होता है? सरफेस माइनिंग यूज होती है उन सभी रोड्स के लिए जो अर्थ के सरफेस पे या उससे थोड़ा लो बिलो मिल जाते हैं इजीली. But when we talk about subsurface, then these are for the ones which are found deep inside earth, and therefore a lot of methods for extraction are used, like drawing tunnels and benches for transport, etc. What are the processes involved in mining? Then there are four steps: grinding or crushing, then sorting. So how is sorting done? Sorting is done by washing the grinded material with water. The next is smelting or heating the ore at high temperature. ठीक है, जिस उस टेम्परेचर तक हीट करना है जहाँ तक कि वो लिक्विफाई हो जाए. Once it's liquid, it can be separated and other elements can also be extracted. Then it's your purification. So what is tailing? Tailing is the waste left behind after your purification. So conservation methods है, mining से damages are retained, like natural landscape gets destroyed, topsoil is removed, and tailing piles lead to pollution of water. Okay, so when we talk about clean emissions, then there is emission of different types of gases like sulfur, nitrogen, carbon dioxide, और ये सारे emissions तब ऑब्जर्व किए जाते हैं जब स्मेल्टिंग प्रोसेस होती है. ठीक है, जब ओर को हीट करते हैं, then at that time these gases, their oxides, they vaporize or they evaporate during that period when the ore is heated or when coal is used for smelting. At that time we see a lot of gases getting released, so they act as pollutants. So this is what is involved in your mining processes. So ये तीनों minings, biodiesel I have discussed. So biodiesel B20 is used from B6 to B20. It's used. So when we say B20 means 20% of biodiesel and 80% of normal petroleum diesel. Okay. So B20 तक यानी कि biodiesel blend 20 तक we do not have to use any kind of engine modification. उससे higher अगर आपको blend करना है petroleum diesel के साथ, then you have to modify the engine. So अभी in today's time such vehicles are not available, therefore only B20 is used. This summarizes your mineral resources and biodiesel. So I'll end the class here. If anyone is having any doubt, then they can send me the screenshot or ask me questions on your WhatsApp. Okay, so Let's just end the class. Thank you all. Have a good day.